Hi everyone. So today we are going to see another problem of array series. Here, so problem says that given an array containing 0 and 1 in random order, and you have to separate out them in such a way that in your output array 0 should always come before the 1. So for example, if you are given this example where 0 and 1 are in scattered manner, like they are in any random order, you have to give the output in such a way that all the zeros, they are coming before all the ones. Okay, so we will start from the very basic approach, and then we will see how we can improvise it, and also how we are going to code them and see their time complexity and the space complexity. So first example that we are going to take, this is very basic approach that we are going to use. So what we are going to do for the first iteration, like we'll run the loop for the very first time, and we will run the number of zeros, and we will count the number of ones present in this array. And once we know that how many zeros are present and how many ones are present, then what we'll do, we will again run the loop, and we will fill the array with initially we will fill the array with number of zeros, and then we will fill the array with the number of ones that we have counted. Okay, so let's see the code of it. I have written the code already so that I don't waste the time in writing the code. So if you see, we have got two arguments. The one is the array, and another is the size of the array, which is denoted by n. So I have taken two variables, that one is I to just iterate over the array, and another is the count _0, which will tell me the number of zeros present in my array. So if you see, I've run the loop and I've counted the number of zeros. So with this, I have counted the number of zeros present in my array, and I have not taken a separate variable for number of for counting the number of ones, because I know that if I do n minus count 0, I will get the number of ones present in my array. Then if you see, I have again run a loop, and I have checked that if count of 0 is present, let's see if in this example my count of 0 is what, 1 2 3 4 5 6, and if you see, count of 1 is what, 1 2 3 4, right? So what I'm doing is, if count of 0 is there, then what I'm doing, array at I am filling it with 0, and then I did my count of 0 from 6 to 5. Then again I went, else wouldn't work in this, then I again incremented my I and checked if count of 0 is there or not. Yes, it is there, I will fill it. Then again I will make it 4. Then again I will fill it, I will make it 4, I will make it 3. Then see, this is how I will just I filled my number of zeros. Now if you check, if you come to this position when I is equals to 6, I is equal to 6, count of 0 has already exhausted, right? Because we have filled from 0 to 5, so count of 0 is not there. What I will do, I will just fill my number of ones here. Okay, so this is as simple as it looks. If you see the time complexity, then the time complexity, if you see, I'm running one loop over here for how much complexity it would take. I'm running it for order of n, and I'm running one loop here, right? So time complexity would be order n plus order n, so it is order 2n, which is of course equal to order n. And if I say space complexity, then I'm not using any extra space, right? Extra space as in I'm not using some extra space of some size n or something, and I've taken these two extra variables, but these do not count as some big complexity, because this will take 4 bytes, this will also take 4 bytes. So 4 bytes plus 4 bytes is 8 bytes, so which is equal to a constant, so it is considered as a order of 1 only. I'm not going into that detail, because I hope that you are aware of these basics. So if you see, time complexity is order n and space complexity is order 1. But if you see, we have wasted two loops in this approach, right? We ran a loop here, and we ran a loop here also. So the question is, the other approach is where we would try to solve this problem in one loop. Okay, so let's see if we could do it. Of course we'll do it. Let's see how we will do it, this approach. Let's see how we will sort these elements in with one loop. So what approach I'm going to use is, I will take two variables, one let's say name it as L, and one let's say name it as R. So first thing, that L would always point to the leftmost side of the array and R would point to the rightmost side of the array, and I would move L to the right side and I will move R to the left side, and I will move with a condition that L always stays behind the R. Okay, L never comes beyond the R. Okay, so you have understood where to keep those two variables and how to move those variables and what is the condition of moving those variables. Okay, now we will make sure that L comes with a condition that if it is zero, because we have to keep zeros in the left side and we have to keep one in the right side. So if it is 0, I will move my L. I will move my L. But if it is 1, just stop. Okay, just understand till here. We will see when to move that also. So similarly, R would come with a condition that if it is 1, I will move my R. I will move R, of course, to the left side, and of course I would move to the right side. And if it is 0, just stop. Okay, now let me show you an example with dry running this example, because I know that with the dry running of this problem you would understand my approach. Okay, so see, this one is 0, and what I've said, if it is 0, I will move my L to the right side. So what I will do, I will move my L to the right side, L will come here. But if it is 1, then stop. So since this is 1, I will just stop here. Okay, now next step, let's see R. What can we do with R? So if it is 1, I will move my R to the left side, but if it is 0, stop. Okay, now if you see, my L is also stopped, my R is also stopped, because my idea was that right side 1 should come and left side 0 should come. So what I will do, if both of them have stopped, I will swap the values, and I will move L to the right side. I mean, I will increment L and decrement R. Okay, so what I will do, I will just swap this. I will bring 0 here, I will bring 1 here, and I will increment L and I will decrement my R. Okay, now if you again see, for L, if it is 0, I will move L. It is 0, so I will move my L here. Okay, now it is 1, so I should stop. Now let's come to R. If it is 1, move R to the left side. So it is 1, I will move to the left side. Again, if it is 1, just move to the left side, right? So I will move to here, I will move R here. But if it is 0, for R, if it is 0, just stop. So I've stopped here. Now I've stopped here, my L is here, my R is here. And if both of them have stopped, what I need to do, I need to swap those two values. So I will bring L here, I will bring 0 here, and I will bring 1 here, increment L and decrement R. Okay, now again, if L is pointing to 0, I have to move the L, right? I have to move the L. But if you see, now both L and R are pointing to the same value, same position. So if you see, the idea of moving this loop is with the condition that L should always be smaller than R. But here, if you see, both are pointing to the same value. Both of them are pointing to the same value. So I should just stop it here. Okay, I should stop here. And if you see, both of them have all of them have already sorted. So this is also 0, this is also 0, this 0, this is 0, this is 0, this is 0, right? So till here my array contains 0, and if you see afterwards here my array contains 1, right? So that is what we also wanted, and we have done it in one loop. We didn't run twice. Okay, so let's see what is the time complexity of this. So Yeah, what is the code for this? First let's see the code, and then we will go for the space complexity and the time complexity. So same function definition, we have got this function called separate. We have got two values, array and int n. I have taken two variables L and R, kept L to the rightmost side, kept R to the rightmost side. Idea is that L should point to 0, R should point to 1. If it is 0, I will move my L. If it is 1, then I should stop. Similarly, R, if it is 1, I will move my R to the left side. If it is 0, I should stop, and if both of them have stopped, I should swap those values. Okay, so if you see the same condition that we have discussed, that this loop should run while L is less than R. So I have checked if I have to continuously run it, right? While array at L is 0 and L is less than R, I have to increment my L. Okay, similarly, if once you have shifted your L, then you will check for the R. If array at R is equals to 1, I will move my R to the left side, and on the condition that L should always be less than R. Okay, now I will just check if both of them have stopped at some point of time. So I have to check if L is less than R with the condition that L should always be less than R. If both of them is less than R, then I will just swap those two values. Okay, I will swap those values, and you can put one extra condition also here, although this is not necessary, but I'm just telling you, although this code has been written keeping that the value in mind, you can take that as a homework and check it. Why I'm saying that this condition is not that much needed, I've just written this condition to make it more so that you get a better understanding of it. But just dry run this without this condition for multiple examples, and you will understand why this condition is not needed. Okay, so if both of them are pointing to the different value, I will just swap these and I will run my loop. So if you see every value now, if you will dry run it, you will see all the values are just iterated over 1 for only once. Like, you have not seen any value twice. Just dry run it. If you see, I have seen this value only once, I've seen this once, this also once, this also once, this also once. So it looks like you're running the loop and again with this and this. It looks like, it appears like we are running the loop, so it might be going multiple times, but every value is being seen only once. So time complexity of this code is order n, and space complexity is order 1, because we have not taken any extra space. And if you feel that there might be a possibility where we are seeing this value for multiple times, there is one more way to write this code, where I have what I've done, I've run my loop L is less than R, and I'm doing one thing at a time. So if array at L is less than 0, double equals to 0, I will do L plus plus. If array at R is equals to 1, I will do R minus minus. So if this is your array and this contains 0 and this contains 1, I moved from this side and I moved from this side. Okay, so this is seen once, this is also seen once. Then if it contains 1 and it contains 0, what I will do, I will just swap them. Okay, and I will increment this and I will decrement this, and we are moving for this condition L is less than R. So if that confuses you, that how time complexity is order n, this is another way to write the same problem, but I don't think that you should be confused with the previous method. So time complexity is order n and space complexity is order 1. Yeah, that's it. Thank you.